Okay, so we are starting into lesson 7.3 today. I say starting because based on past experience, I don't feel like we'll get done with the notes, at least not in any way, shape, or form that I can walk away feeling like you guys, know what you're doing. So, with that in mind, let's get started. We are talking about logarithms today. So this is, I believe, a brand new topic to you. Yes. I don't believe it's something that comes up in Algebra 1. We're talking about logarithmic functions and inverses. And why this comes up is because, we spent the last two lessons talking about exponential functions. The logarithmic function is the inverse of an exponential function. You will also notice on your calculator that we have log buttons on the calculator. So any scientific calculator is going to have a log button. There's an log button, which is the log we'll be talking about today. And then there's also an ln button, which is also a log button, but I don't think we get to that till, I think, towards the end of the chapter. I don't think we don't talk about natural log until lesson 7.6. So, logarithms. A basic logarithm looks like such, where it's log, a little b, which is like a subscript, an x, and equals y. If you look at the parentheses, it specifically talks about when that's red, actually no, it's down below, I guess. It's red, log base b of x equals y. So this is log base b of x equals y. So when we read our logs, we read that little number as our base. So log base b of x equals y. Now, this log that we're talking about is equivalent to this equation right here. So log base b of x equals y is equivalent to the exponential function b to the power of y equals x. Those are equivalent. One of our big things we're doing today is learning how to go back and forth. Okay, if I give you the log form, put it in exponential form. If I give you the exponential form, put it in log form. So I already mentioned here, logs like the one above are red. Log base b of x equals y. I mentioned this. Logarithms and it's the next line. In that, I'm going out of order, sorry. They are inverses of each other. Okay? They are inverses of each other. The big thing we're talking about, logarithms and exponential functions can be switched back and forth by thinking left, right, middle. Okay? If you ever see me write LRM on your paper, on a test, on a quiz, or if you see me write it in my notes, it stands for left, right, middle. And it's just kind of a memory phrase to help us go from log form to exponential form. So, for example, log base 2 of 8 equals 3. The idea of left, right, middle is 2 is that base of 2 is our left because it is the first thing listed, yes? Okay. That makes the 8 the middle. And guess what the 3 is? The 3 is your right number. So when you're in log form, base is left. That main number inside the log is our middle. And what it equals is the right. When we say left, right, middle, what it means is we can rewrite this. The left raised to the power of the right equals the middle. So 2 raised to the power of 3 equals 8. And thus we have left, right, middle. So when you reorganize them, that's the new order. So base, raised to the right. So left raised to the right equals middle. Left, right, middle. 2 to the third equals 8. That's going to be one of the big things we're doing, guys. To have some success in this chapter, you've got to be familiar with the phrase left, right, middle. And we're going to apply it down here, so hopefully that will make some sense to you. A comment I need to make. The inside parts of a logarithm can never be negative. Now, where are the inside parts to a log, you might ask? Where this 8 is, that's the insides of the log. Or up here where the x is, That's the insides of the log. So the base would never be negative also, but the insides of the log can never be negative. If you get a negative, you can't work the problem. If you, on your calculator, type in log of 8, it'll give you a number answer. Okay? Doesn't mean a lot to you right now, but it gives you a number answer. If you type in on your calculator log of negative 8, your calculator is going to give you an error of some sort. Okay? Because you can't have a log of a negative number. Now, I talked about that log button on your calculator, right? That log button on the calculator represents something called the common logarithm. Common logarithms are logarithms like those above, but they always have a base value of 10. So as we start talking about logs, if we don't mention a base, the assumed is that it is a base of 10. Your calculator, it doesn't have a base listed on your calculator. Your calculator works in log base 10. Your calculator only works in log base 10. Okay? If it's a log base 10, we don't write the 10. It's kind of like an invisible 10. So something like log base 10 of 100 would just simply be written as log of 100. Okay, so there's that invisible 10. Kind of like if we talk about x, there's an invisible 1 in front of the x. Common logs have that invisible 10. Now, as long as there is a log number, then it's given. So like if you look down at example 2, log base 8 of 32, log base 5 of 125, log base 4, the bases are there for the most part. Just realize if they don't give you 1, it's an assumed 10. Okay? So that's just kind of, a whole bunch of information. Doesn't all necessarily make a whole bunch of sense yet, but we'll get there. Now, our job on example 1 is asking for what is the logarithmic form of each of the following. So they're giving me the exponential form. My job is to take it out of exponential form and put it into logarithmic form. So if you compare it to the top row of the notes, we're taking it out of b to the y equals x form and rewriting it in log base b of x equals y form. It's also kind of, you're reversing the whole left, right, middle idea. We'll use left, right, middle down here in the next part, but we're reversing the left, right, middle. So when I write this, 10 squared equals 100. I want to write it log base of something of some number equals some number. My three numbers are the 10, the 2, and the 100. Thoughts on what goes where based on what you're seeing?
How would you say it?
Just go ahead and study your way through it, and I'll fix it at the end.
10 below, like on the bottom, 2 equals 100, something like that.
Okay, so you're saying your 10 is your base, is what, that's, the little number is the base. Now, however, I do disagree with some of your number locations.
Oh, okay, yeah.
Okay, so if I rewrite this, okay, and again, I know we'll get the verbal, how we verbally say it. I'm not as concerned about that, and that was Jake's question up here, but it is log base 10 of 100 equals 2. Okay, so we're kind of reversing the left, right, middle. I know one thing I look at is this exponent had a base of 10. What's the base of the log? 10. And then what happens with the 2 and 100? They flip-flop. I don't know how you guys necessarily, there's different ways different people think about it. You have to come up with what works for you. Yes? Okay, so yep, I was going to get to that next. Right now, I wrote it as log base 10 of 100 equals 2. Technically, I would not count that wrong. Math Excel, you never know. They might count you wrong, but I'm not going to count that wrong. Okay. However, what is another acceptable way to write this? It's a base 10, so that's the invisible 10. And the other way to write this is log of 100 equals 2. This is new. I'm fine either way. Okay? So, if you think left, right, middle, does it go back? So it's base 10 here, so 10 is my left. So left raised to the right equals middle. 10 to the second equals 100. You can redo it there. Everyone have a way they see that? Everyone with me? Okay, let's try C. 1 equals 3 to the 0. Now, if you're okay with it like that, that's fine. If it's helpful, I don't know. Does it work better in your brain if you see it as 3 to the 0 equals 1? Some of you are going to say it doesn't matter either way, Mrs. Sargent. Some of you are going to say, oh yeah, that helps. Okay, here's my help. Log. Log base of what equals what? Log base 3, can we agree with that? Yeah. 3 is the base of my exponent, so this is 3. Log base 3 of 1 equals 0. Okay. Now, this one, I have to leave the base, yes? Okay. We can reverse it. Left, right, middle, 3 to the 0 equals 1. That still works. Take a guess what the rule is that we're kind of learning in this case. Log of 1 is always going to equal 0, no matter the base. Okay, so just a handy dandy little rule to know there. Log any base of 1 always equals 0. Okay. C. Did you rewrite it on your own paper? What do we have? I like it. You guys like it? Yeah. Okay. Now, and I don't know. Did anyone have to rewrite it like that? Maybe you guys are past that. Good deal. So, log base 3 of 81 equals 4. Okay. The last one. Should we skip it because it has fractions?
No.
No. Okay. Is this any more difficult because it has fractions? No. It's the same thing. Just because it has fractions does not mean it's impossible or difficult. Okay, so D. There you go. There's my help. What'd you guys end up with? Okay, it doesn't look pretty. Log base 2/3 of 8/27 equals 3. It's something to memorize, guys. It's something to just flat out know how to go back and forth between those. Questions there? Okay. Next section. What is the value of each log? Log base 8 of 32. What is that equal to is what I'm asking. Can we plug this in on our calculator and give me an answer? What did I say about our calculators? They're log base 10. Okay, so the point being, unless it's log base 10, I can't just plug this into the calculator. Okay, so we have to talk about a method here. My suggestion is that make your log equal x. If I have log base 8 of 32 and I just said equals x, what thoughts do you have on that statement there? What thoughts do you have, Ethan? Okay, let's change into exponential form and see what it looks like. So log base 8 of 32 equals x. So this is our left, right, middle. What is this going to be in exponential form? left, right, middle. So it's what? Yeah, 8 to the power of x equals 32. Okay, so base 8 raised to the power of x equals 32. Left, right, middle. So now we're going the other way. Okay. Solve for x. Thoughts on how to solve for x here? What? I forget what you mean by that. Well, the problem is because I have this x here, I can't really touch that 8 in the sense that I can't like divide anything out there. Here's what I need you guys thinking. And I'll start you here and see if you guys can figure anything out. 8 and 32. Can we rewrite 8 and 32 so that they have the same base? So can they be rewritten with powers so that they have the same base? I'm trying to give you guys a moment to think before I go any farther here. See if anyone can come up with anything. So, 8 and 32. Can they be rewritten with the same base? I don't know if the blue paper will help you get there or not, but it might. What? Well, can I square root 8 and 32? Can't square root them. What's something you can tell me about 8 from this paper? It's a what? It's a cube root, yes? The cube root of 8 is 2, which means 8 can also be written as 2 to what power? 2 to the third. Okay? 32. Thoughts on 32? It's a fifth root. What's the fifth root of 32? 2. So how could I rewrite 32? 2 to the fifth? Work with me here. So 8, you just told me, was 2 to the third, yes? And this is raised to the power of x. 32, you just told me, is 2 to the fifth. Did I just rewrite these with the same base? Yeah. Okay. The idea that 8 is 2 to the third, 2 times 2 times 2. 32 is 2 to the fifth, 2 times 2 times 2 times 2 times 2. They have the same base. That's the important thing. Now, okay guys, what do you remember about exponent rules? If it's 2 to the third raised to the power of x, what do you do when you raise a power to another power? Not add them, multiply them. So 2 to the third raised to the x can be rewritten as 2 to the 3x equals 2 to the fifth. Okay, guys. What do you think if the bases are the same? Guesses on the powers? They have to be the same. If this is an equation, it says 2 to the 3x equals 2 to the fifth. My 2's are already the same, yes? So what's that mean about those powers? They have to be the same. So the technique here is, since my 2's are the same, drop the 2's off and set your powers equal to each other. So my equation that I have to solve is now 3x equals 5. Can you solve that for x? If it's 3x equals 5, how do we solve for x? Divide by 3. What is x? 5/3. So guess what log base 8 of 32 is equal to? 5/3. The idea here, if I did 8 to the power of 5/3, I'm going to get 32. So if I do, I'm going to take you this way, 8 raised to the power of 5 divided by 3, my calculator is going to tell me it's 32. Okay, so there's your proof. I can't punch in on the calculator and show you that log base 8 of 32 is x, but I can show you that. Hello? She hung up on me. I guess so. Okay, guys. Questions on that one? Okay, ready to try the next one then? Let's try the next one. Log base 5 of 125. What did I start off with? Setting it equal to x. What do I do to get out of this form? What's my phrase today? Left, right, middle. So if I rewrite this using left, right, middle, how does it rewrite? Okay. 5 to the x equals 125. What are you asking yourself here? Can we make them have the same base? Blue paper might be somewhat helpful here. It's not exactly organized for this, but it might be somewhat helpful. I mean, I've got a 5 and a 125. 5 is just kind of 5, but is 125 on this paper somewhere? It's a cube, isn't it? 125 is, the cube root of 125 is 5, so how can I rewrite that? 5 to the third. 125 is equivalent to 5 to the third. Did you guys know that one? Okay. And that's, you're going to have a little more success here if you just know them, but we're going to work on learning them. What about 5 to the x? Just leave it, yeah. Because, and does that work for us? I mean, 5 is a prime number. I can't take any root of 5. So 5 is a prime number. It's just going to say 5, so that's 5 to the x. 125 is 5 to the third. Thoughts? If my bases are the same, then my exponents are the same. What are my exponents? X and 3. So what do I know? X equals 3. Any more solving? No. Okay, so last chapter, you had a blue paper. You can still use the blue paper. I'm not taking it away. I'm not saying you can't use it. However, this chapter, you might find this yellow paper a little more helpful. And some of you may be asking, why didn't you just hand this out from the beginning? But I wanted to make you think some. Okay. So did you see what I did on this yellow paper? Instead of writing them in terms of roots, I wrote them in terms of powers. So that first column is all of your powers of 2. Next column is powers of 3. Then I kind of start overlapping. You got powers of 4, powers of 5, powers of 6, powers of 7, 8, and 9. Could you add on to this list if you find something that you don't think I went far enough? Sure. Okay. But see, these are some of the basics I feel like you're going to see. Again, these are just numbers to be familiar with. They're helpful going on. But I thought it might help if you guys have them in front of you. Okay. You ready for C? What am I doing? Log base 4 of 32 equals, I personally am going to put an X there. Okay, how can I rewrite this? Okay, left, right, middle. 4 to the power of X equals 32. What are you doing at this point? Getting our bases the same. Okay? For the purposes of today, your bases will always be able to be the same, somehow or another. It's just a matter of figuring out how. So 4 and 32. How can I rewrite 4 and 32 so that they both have the same base? Is it easier to figure out now with the paper in front of you? Okay. What am I looking for on this paper? Where 4 and 32 are in the same column, yes? And I have 4 and 32 both in the 2 column. So 4 can be rewritten as 2 to the second. If it's already 4 to the x, when I rewrite this as 2 to the second, it's going to be 2 to the 2x. What about 32? 2 to the 5th. And now, if the bases are the same, what do we know? The exponents are the same. So if 2x equals 5, what is x? 2x equals 5, divide by 2, and x is 5 over 2. Okay, you starting to catch on? Okay, good. Let's throw a fraction at you then. Can't let you catch on that much. Gotta change it up. Okay. Step 1, no different than the others. Log base 64 of 1 over 32, I'm going to set equal to x. What is my exponential equation I can write? Has everyone gotten that far? What are you writing here? Okay, good. 64 to the x equals 1 over 32. Okay. Don't stress about the fraction for right now. We'll deal with the fraction in a moment. I see 2 numbers there, 64 and 32. What can you figure out about 64 and 32? What? It is half of 64, but think in terms of bases.
4 to the 3rd.
Okay. Where can I find 64 and 32? In the 2 list? Now, you do have to be careful because 64 is in that list. 64 is also in the 4 list. 64 is also in the 8 list. But which list is better this time? The 2 list, because not only is 64 there, but 32 is there. So let's rewrite with these powers. 64 is 2 to the 6. So if it's 64 to the x, this is 2 to the 6x. 1 over 32. This is going to be 1 over 2 to the 5th. I'm oh so close, but not quite there. Because what I need is I need a just plain old base of 2 on both sides. No fractions allowed. So I need it to be 2 to some power equals 2 to some power. How do I do this? Yeah. If you have a negative exponent, to get rid of a negative exponent, we normally take it to the denominator. So how can I get out of the denominator? Put the negative exponent on it. So what we're saying here is that 2 to the 6x equals 2 to the negative 5th. So you solve the 32 as 2 to the 5th. To get it out of the denominator, make that a negative 5. And now, I have like bases, yes? If 2 to the 6x equals 2 to the negative 5, then what do we know? (6x) equals negative 5? If 6x equals negative 5, what's x? Negative 5 over 6. Okay. Last one in this section. Log of 1,000. What are your thoughts here? Connor?
Can't you just type that in?
Can we just type it into the calculator?
Yeah, it equals.
Okay. Okay, so this is a good calculator experiment. Now, sorry to be the bearer of bad news, we're also going to work it out, because I want to show you that they're equal, okay? Okay, so I was told we could type this into the calculator because this is an invisible base 10, right? If we set it up otherwise, log base 10 of 1,000 equals x. I just want to show you something here, so I'm going to go through it. I'm not disagreeing with the answer of 3. I like it. What is this? 10 to the x equals 1,000. Now, I didn't put tens on your yellow paper because I would like to think we know those. Okay? 1,000 can be rewritten how? There's how many zeros? 3 zeros, so 10 to the third. So 10 to the x equals 10 to the third. Realize 1,000, because it's a 1 with 3 zeros, it's 10 to the third. If it was 100, it's a 1 with 2 zeros, 10 to the second. If it's a million, 6 zeros, so 10 to the sixth. Count your zeros. So 10 to the x equals 10 to the third, guess what? X equals 3. Did your calculator agree? Yeah. So that is a good test run. And as I said, we'll do more later in this chapter. But that is a good test run of knowing how to use your calculator. My calculator is very straightforward. I hit log. I enter 1,000. It gives me 3. Some calculators, I don't know. Do some of you guys have to enter it in backwards order possibly? Sadie, do you? Okay. So, you know your calculator. But the point is there to make sure you know how to use it. Okay. As much as I would love to do the next problem, we will stop there. We will pick up tomorrow. I don't know. There's a chance. I would like to think maybe you guys could have some work time tomorrow. We have to look at these word problems, which are pretty easy. We have to look at a couple of graphs. So, might be able to get you guys some work time. So feel free to start working on the homework. It's not due until Monday, though.